All right, so we're going to be facing rational equations today. So I've got this equation right here, and I want to find the possible value or values of x that make it true. Okay, so the general strategy is that you want to factor the denominators, and then you're going to want to multiply the equation by something that cancels out the denominators, that clears them out. All right, we used to do that whenever we had little linear equations like this. Like if you multiply this equation by 2, okay, it's going to cancel out this fraction part. And so 2 times 1/2 x would leave you with just x. And then you'd have 2 times 4 is 8 and 14. Okay, we've used this strategy before where you multiply the equation by something to cancel out the denominators. All right, and then the last thing you want to do is you want to solve whatever equation is left over and then check your answers, because sometimes there's one solution to these, other times there's 0 or 2. All right, the denominators here will not factor. All right, x won't factor, x plus 2 won't factor. What I want to do is I want to multiply this whole equation by something that will cancel out these denominators. Okay, so it's actually going to be the least common multiple for whatever is in the denominators. But the way I do it, I look at what I need for each piece. Like if I want to cancel out this x plus 2, I know that I have to multiply by an x plus 2. Okay. Now that x plus 2, it'll cancel that, but it will not cancel this x. Like if you had an x plus 2 over an x, the x's don't cancel. So I'm also going to need to multiply this equation by an x. Right? So I'm going to multiply each of these 3 terms by this expression right here. So the way it plays out is when I multiply the x plus 2 by this, the x's will cancel, and so that's going to leave me with 4 multiplied by x plus 2, which is 4x plus 8 plus. All right, and then for this times this term, the x plus 2 parts will cancel, and so that's going to leave me with an x times an 8, so 8x. And then the last part, there's nothing in the denominator, so nothing cancels. It's just going to be 4 times x plus 2. Okay. Now that you've got the denominators taken care of, you're just going to solve whatever leftover equation you have. So general equation solving strategies here. Combine like terms, 12x plus 8, distribute, 4x squared, 4x times 2 is an 8x. All right, I've got a quadratic equation and I've got linear terms, so I'm going to need to move everything over to one side of the equation. I'm going to move these 2 terms over to this side. So move that 12x over, move that 8 over. Okay, it's going to give me 0 equals 4x squared minus 4x minus 8. Now from here, if you just want to throw it in the quadratic formula, you can. Remember we have that quadratic formula program, all quad. Okay, if you want to use that, I will be using that later, but this one can be solved by factoring. First thing to notice here is that everything's divisible by 4, so divide the whole equation by 4. 0 is equal to x squared minus 1x minus 2. And then we can solve it by factoring this quadratic. X and an x. This has got to be a 1 times 2 in order to give me a 2. And the 2 needs to be negative. Okay, so your answers for this equation are going to be negative 1 for this factor. X is equal to negative 1, and x is equal to positive 2. Okay. You would want to go ahead and plug these answers back in. All right, it's not so important right now. As long as you followed the steps correctly, these will be good solutions, but I'll show you one later where you actually have to be careful, right? So if you want to check your answers, plug these in for x and see if you get 4. All right, we'll do one more. All right, for this equation, notice how the denominators are not in factored form. What we need to start off by doing is factoring them, okay? So I'm going to have x plus 6 over x minus 3. That's factoring out an x. 2 over x minus 3. And then for this one, they have a 2 in common, so I can factor out a 2. So it's 2 x minus 3. All right, now that the bottoms are in factored form, now I can see what I have to multiply by in order to clear that denominator. All right, looks like the x minus 3 is pretty important. I know I need an x minus 3 to cancel those parts out. So I'm going to multiply by an x minus 3. I need an x in order to cancel that out. And I need a 2 in order to cancel that out. Okay, and that will clear my denominators. Okay, so when I do this times this term, all right, the x and the x minus 3 cancel. So I'm just left with the 2 and the x plus 6. Okay, I'll write it in factored. I won't distribute it this time. You can if you want to. I'm just going to not do it. For this term, the x minus 3's cancel. So I'm left with a 2x and this 2 up top. There we go. All right, and then for the last one, the 2's cancel and the x minus 3's cancel. So I'm left with a 3 and an x. All right, we'll distribute here. We're going to get 2x plus 12 minus 4x equals 3x. All right, this one is not a quadratic equation, just a linear. So we're going to get one solution this time. Okay, so 2x minus 4x is negative 2x. I can move this 2x to the right-hand side. So I get 12 equals 5x, because you have to add 2x to both sides. And so 12 divided by 5 will be my answer. So x is equal to 2.4. All right, that is my solution. All right, let me go ahead and actually plug this in so you can see how to check your answers. It's not crazy. Just 2.4 stow to x. And then we'll type in the left-hand side. All right, alpha y equals x plus 6, x squared minus 3x minus 2 over x minus 3. All right, this is what you get for the left-hand side. When we do the right-hand side, we should get the same thing. 3 over 2x minus 6. There it is, same answer. Okay, so 2.4 is our only solution for this rational equation.